Let's quickly go through a number of built-in arithmetic functions in Haskell, which you would expect any programming language to support. You can use addition, subtraction, and multiplication as you would expect, and as we have seen in previous code examples. In these examples, we are operating on two ints and returning an int, and so the type signature of int is satisfied. Now let's look at division. Consider this simple example where we declare d to be an int equal to 20 divided by 2. Now in our head, we know it should equal a whole number, 10. This will fail to compile with an error message, which you will more than likely not understand at all at this point. Let's take a look at this error message. No instance for fractional int arising from a use of division in the expression 20 divided by 2. What does that even mean? Well, to tell you the truth, you won't be able to truly understand this error until you have understood something known as type classes in Haskell, and we are not going to cover that until later in the course. So for now, I'm sorry, but we won't be able to fully understand this error message. Don't worry though, when we cover type classes, I'll make sure to come back to this example and explain it properly. For now, just understand that when using the slash to perform division, the type needs to be a fractional type. And double, which is a type we know, just happens to be a fractional. An int is not a fractional, and so this does not work. So if we replace the type with a double, everything works fine as we would expect. Let's take a second to pause and understand conceptually what happens when you divide something. In this particular case, we are dividing 20 by 2, which we know by performing the calculation in our head will result in a whole number, 10. And so an int should work here, right? Well, yes, in this specific case, but no for the general case. For this example, we may be able to perform the calculation to see that it should result in an int, but in the general case, there is no way to know that in advance. I mean, if we knew the result of a calculation in advance, then there would be no need to perform that calculation since we already have the result. Division, by definition, creates a fraction, and so by definition, having division return an int in the general case makes no sense. In some other languages, what happens is that some implicit rounding and conversions take place to allow this type of code to compile, but Haskell is strongly typed. Everything needs to pass the type checker, and so any rounding or type conversions need to be explicit. So on the issue of basic arithmetic, you may come across errors like these. Remember, if it says no instance for fractional, try changing the type signature to be a double instead. As a beginner, these errors will be annoying, but once you understand Haskell more, and in particular type classes, you will find it quite useful. But this still does not answer the question for our specific case. In our case, we know 20 divided by 2 is a whole number, and we don't want a double, we definitely want an int. In that case, we can use the div function. The div function will perform the division, then round down to the closest int. Unlike the built-in arithmetic functions, which we can place in between the two arguments, just like we would do in mathematics, for the div function, we can't do that by default. Instead, we pass the two numbers to be divided to the div function, and we do that by putting them next to each other with a space between them, just like for the simplest functions we saw before. Another arithmetic function I would like to show you is the negation function. The negation function, or negation operator, is a built-in prefix operator in Haskell, which is just a dash that you put in front of a number to turn it into a negative number. You can see how it is used in the code. Where there is potential confusion over functions or inbuilt operators, it makes sense to put the number as well as the dash in brackets to avoid ambiguity. The final inbuilt arithmetic function I want to show you is exponentiation, which you perform by using the caret symbol. So in this code example, we are raising 2 to the power of 3, which is obviously 8. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Learn channel. See you next time.